Hello. Hello, geometry class. All right, so this week, this section, we start getting into the triangles and their centers. It's kind of annoying because there's lots of them, so I highly recommend you either make a cheat sheet, something, because they all have very confusing names and they all have different rules, okay? So for reference when you're taking tests or quizzes, it's nice to have something and then you don't have to flip through lots of web pages because now you don't have physical copies of the worksheets anymore. Before I always keep the worksheets because they're helpful. So the first one we're talking about you get from taking the perpendicular bisectors of triangles. So I'm going to kind of point out what that means first because we haven't really dealt with this. So a perpendicular bisector is what it sounds like, right? It bisects one of the sides of the triangle, okay? And it hits that side perpendicularly. The thing that's different, and you can see from this one, is where it comes from is based off that side, not the other part of the triangle. You're used to seeing ones like this, where you take the one of the corners, the vertexes, and drop it down, and it makes a perpendicular bisector. But that's not always the perpendicular bisector. It can be, but this is more technically a perpendicular bisector. Okay, so the way you would find it is how it sounds. Like you would find where is the midpoint of this line. Okay, figure out what the slope of that line is, then draw a perpendicular line through it. Boom. That is how you find the perpendicular bisector. Some of the things come from that are pretty easy and make sense. Like, look at this. It says, okay, if WY is 24, what is WX? Well, if this whole length is 24, what's this piece? Well, it's half of it. So if this whole thing is 24, that's 12. Easy. Moving on. All right, here's the part I was referencing with the centers. So if you take the perpendicular bisector of each side of a triangle, the three of them will meet at a point in the center of the triangle that is called the circumcenter. Okay? And again, these get confusing. There's circumcenter, orthocenter, incenter, and there's a fourth one that I can never remember. But circumcenter, orthocenter, incenter, they all are different. They all have found different ways. They all have different properties. The circumcenter, which is the one we're doing here, is found with perpendicular bisectors, and this centerpiece is equidistant, or the same distance from each of the vertexes. So from X to B is the same distance as from X to C and X to A. Okay, that's what circumcenter means. So then looking at this part, okay, so if XA is 8, so if this length is 8, what's XC? Well, it's the circumcenter, so they're the same. If that's 8, that's 8. Done. That is the basics of this section. Of course, it's going to get a little more complicated. I'm going to do one of the more complicated problems right now. But let's go over to the practice. I'm trying to keep this quick so that I don't lose all of y'all. Okay, so here we go. If XY, this piece, right, is 15.5, figure out what this is. Well, you're kind of using Pythagorean theorem and other stuff. So we have this is 15.5. These are the same. That's half of it. Whatever. You can figure it out. Well, actually, yeah. Sorry. Moving on. We'll do this stuff on Friday too. Given the line, so it's a lot of here we go. Here's some algebra. Given that xy is yz, xy and is equal to yz, wx is 6x minus 1, and where's xz? And xz is 10x plus 16. So this is the same as this. So 6x minus 1, 6x minus 1. So basically, this plus this equals the whole thing. Solve. Anyways, moving on. I want to move on to this guy right here. Find the circumcenter of the triangle with the given vertices. Okay, these is about the most complicated problems you'll get in this section. Okay, they gave you 3 points, and they want you to find the circumcenter. So again, to find the circumcenter, I need to find 3 perpendicular bisectors. Okay, first step is to plot it, which, boom, there we go. It's plotted. There's my triangle. So the first thing I need to do is find the perpendicular bisectors. Let's see, can I draw on this? don't think I can. So what I'm going to do is I'm going to take this and I'm going to draw a triangle similar to this on a separate thing that I can draw. Oh, I forgot to make a new one. That's my Algebra 2 one. I have to move my face because my face is covering the button to make a new one. So I'm trying out this Jamboard thing. I know Mr. Purdy uses it a lot, and he's like, this is amazing. Jamboard's so great because like you guys can write on it. I like it because it's like the whiteboard, but I can do multiple pages and I can save it. Okay, so let's make that triangle. So I'm going to make that triangle. Looks like this, right? This point is 0, 0. This point is 5, 0. And this point is 0, 5. It's a little laggier than the whiteboard, which is why I don't use it in class. But it works for this. Okay, so now I need to find the in-center. It's going to be somewhere in here, right? And so to do that, what I need to do is 2 steps for each side. I need to find the midpoint of each side, okay? And then I need to find a line that is perpendicular to it, okay? And I will show you a cool hack that we can do. All right, so from 0 to 5, halfway of that would be at 2.5, right? So that's going to be at 0, 2.5. Pretty easy. Midpoint of this one is also going to be at 0, 2.5, right? Halfway point. Pretty easy. So now I would need to figure out what the slope of the line that goes through this would be. Well, hey, this should be pretty easy, right? Because it's a perpendicular line to a straight line. So the slope of this one is just going to be straight up and down. So to graph that blue line, I would say x equals 2.5, right? And then this one is going to be a horizontal line, so I would say y equals 2.5. So that means they should hit right here at 2.5, 2.5. Okay, that is the circumcenter of this triangle, but we're going to do a little more just to kind of help prove things. We're going to double check. Okay, so I want to double check this. So I want to figure out what is the midpoint of this line. So first thing I need is the midpoint theorem. Remember that was x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that will tell me the midpoint of that line. Okay, so I've got these two things, so I'm going to take my 2 x points. We have 0 and 5. So we have 0 plus 5 divided by 2, 2.5. Done. All right, we're going to take the y values. 5, 0. So we have 5 and 0 plus 0 divided by 2 equals 2.5. All right, we got our midpoint. Boom. So now what I need to do is figure out what is my slope of this guy. Okay, so it went from here to here, so it went down by 5 and over 5. So that means my slope of this line is negative 5 over 5. Right? So negative 5 over 5, which becomes negative 1. So if that's my slope of this line, I need to have a perpendicular slope. Okay? So let's draw my perpendicular slope. Remember, perpendicular, you take this number, you flip it, and you change the sign. So negative 1 over 1 becomes positive 1. So my perpendicular slope is going to equal 1. So far, so good. Cool. And now what I want to do is I want to, like, if this was the long way of doing this, like if you did not have 2 straight lines, you would then find what the equation of this is. And you'd want to figure out where those 2 lines hit. And a lot of the times you'll use Desmos. Okay, but in order to do that, you need to come up with the equation of it. So let's figure out what the equation of this line is. I have the slope, I have a point. Okay, and I'm using the point that I got from the midpoint, not the red one. So let's go over a new page. Come on, there we go. So I have my slope, equals 1. I have a point of 2.5, 2.5. So you can do this two ways. You can do it the way that Ms. Flassati recommends, and a lot of other people recommend, which is the point-slope formula. I hate the point-slope formula. I've told you this before. The point-slope formula is this. Y minus y1 equals mx minus x1. You plug these three numbers into that, solve for y equals mx plus b. Dot. I like y equals mx plus b. So I'm going to say y equals mx plus b. I need to figure out what b is. Okay, so I'm going to plug in y mx plus b. So let's plug stuff in. My slope is m, so that's 1. My points are 2.5 and 2.5. Multiply my stuff together. We got 2.5 equals 2.5 plus b minus b equals 0. Sweet. So b equals 0, my slope equals 1. I plug this guy in here and this guy in there, and we get y equals x. So that's my equation. Okay, so now what I would do is I would go into Desmos and graph those equations. So let's look at those equations real fast. So we had x equals 2.5, y equals 2.5. So let's write these down. We got x equals 2.5, y equals 2.5. So I'm going to graph these three equations. Y equals x, x equals 2.5, y equals 2.5. And they should all intersect at the exact same point, which should be at 2.5, 2.5. So we've got y equals 2.5, okay? X equals 2.5, okay? So that's what we've got, right? We got that those two intersect at 2.5, 2.5. Now the trick is our third one should do it as well. Y equals x, boom. All three of them intersect at 2.5, 2.5. So again, I know this is kind of a mess, but if you do not have a right triangle, what you can do, you only need two of the perpendicular bisectors, okay? So generally one of them will be flat like this, right? And then the other two might be curved, or by curved I mean slanted, that they're not on the x or y axis. But figure out two of them, graph them on Desmos, where the two intersect, that's your answer. Okay, that's the best way to do this. Okay, 13 minutes. It's a long time, but that was a tough problem. That's kind of the toughest for this section. So we'll talk more about this on Friday, and yeah, I'll make a new video in a few minutes. Adios all.